All right, everybody ready to get started? All right, everybody, welcome to DPRIVE. Hey, Benno, can you start beating people up? No. Hey. All right. All right, everybody, this is DPRIVE. Welcome to Montreal. We have a relatively quick, relatively full agenda, so I want to make sure that we get through everything as quickly as we can. For those of you who know me, you've seen me here before. I have a new and improved stand-in co-chair. Let me know if you think it's better and or worse than having Tim up here.
That's how we find out if Tim is remote.
Right. Everybody should be familiar with this by the time you've gotten to Thursday. This is the note well. Here are all the documents that you should have read at some point in time. There is no quiz, so you're on your own. If I get any closer, I think I'm going to eat it. So I will talk louder. So is that Sean? It is? Are you sure? Okay. All right. We do have at least one person who volunteered to do Jabber. So Dan York gets the grand cookie for the end of the meeting. Do I have a volunteer who will actually do some minutes for us? Thank you, Paul. Here's our agenda. We do have a slight bash to this agenda already. The using early data in DNS over TLS is going to get moved up so that the presenter can go to HTTP biz. Anybody else have any changes that they would like to see in this before we get started? Awesome. So, a couple of quick things before we move along. Over in the DNS-SD working group, there are two documents that are looking at privacy implications of their discovery mechanisms, and they've been looking for people willing and able to review them and provide feedback. So, part of this is due to the fact that DNS-SD is potentially winding down. So there may be a poll at some point as to whether or not we might want to adopt these documents. But in the meantime, anybody with an interest in DNS service discovery and privacy implications, please go take a look at these drafts and provide some comments to either the authors or that mailing list. If you recall, coming out of Prague, we did an adoption call for the 7626 biz document. We have adopted that. That document is now available. The authors would really like to see some reviews and comments. The big thing here is that this is a normative reference for the BCP document, so we want to make sure this moves along as quickly as possible so we can finish up the BCP. Any comments, questions, going once, going twice? All right, so let's do the DNS over TLS and early data. Alessandro?
Hello. For those not aware, TLS 1.3 introduced a feature called zero RTT session presumption, which allows clients to send application data before the TLS handshake has completed in order to reduce latency or whatever. This can be useful for DNS over TLS in cases where keeping long-lived TLS connection might not be feasible. For example, on mobile clients where the network might be shaky, or on resolvers where maintaining a large number of connections to authoritative servers might not be feasible. However, this comes with caveats. Notably, the early data can be intercepted by on-path attackers and replayed to the server. The attacker cannot directly decrypt the data but the replay might have unexpected consequences or bad consequences. So so the TLS 1.3 RFC defines some mechanisms to mitigate this replay potential, and also says that application protocols have to define a profile so that that defines like safe ways to use early data for the specific application protocols in order to actually use early data. So this is what the draft does. It's mostly based on RFC 8470, which is the using early data with HTTP, because most of the mechanisms are common. There are some DNS-specific bits, for example, defining which DNS messages are safe to or unsafe to send over early data, as well as some of the security considerations. So there was a discussion on the mailing list. There was some interest in the draft, and some suggestions were proposed. So, for example, currently the draft defines a blacklist of DNS messages that should not be sent over early data because of the replay problem. So, like DNS updates or zone transfers. It was suggested that it might be better to define a whitelist of messages that are safe to send, for example, using a IANA registry. And then the privacy considerations sections need some work. So, as I said, there seemed to be some interest on the mailing list. So I guess the question is whether the working group wants to adopt this. And that's it.
Stefan Bartsmeyer, one clarification about the whitelist. You talked about allowed R types, but it's actually opcodes, not R types, I assume.
I guess it would be RR types, I think.
Because
or
the examples you gave were all examples of specific. No, it's update is an opcode, but AXFR is a R type.
Right.
So it's.
I mean, we can discuss this more and define this as a more complex mechanism if required.
Hi, Carl Henderson, VeriSign. Did you look at any of the possible side channel attacks with replay or consider that?
Right. So there's a security consideration section that describes at least one of those attacks. This was discussed more than a year ago between DKG and I don't remember who. But yeah, so there was another attack that was proposed due to caching, for example, that needs to be written up.
So how many people in the room have actually read this document? I see about 4 or 5 hands. Okay. So what we'll do, Alessandro, is solicit some more reviews, and we can do a call for workgroup adoption on the mailing list.
Okay. Thank you.
Yeah, that's right. All right, this is an update on the DNS privacy operations BCP. Sarah asked me to do the presentation, but I don't want to take credit for all the hard work she did improving the draft, so some appreciation for that work. Brief introduction. The end goal of today is that we want to ask whether the working group thinks that this can go to working group master core or not. Just a recap of the document goals. The goal of this document is to set operational policy and security considerations for DNS operators that operate the DNS privacy service. And it also includes the DNS privacy policy practices statement, which is a framework that operators can use to sort of describe how they run their service. And we combined these two in a document, and I'll get back to that too at the end of the presentation. So in revision 3 of the document, we made a number of updates based on comments on the mailing list and some discussion that happened in the working group at the past IETFs. One of the things that we did is that we added clarification for the purpose of the DPPS, which is to basically let operators sort of demonstrate their commitment to privacy, create user choice, and also sort of have a common framework for this, so that if people compare statements from different operators, that they sort of recognize the commonalities between the two or the differences. We've added DNSSEC validation as a requirement in the document if you run a DNS privacy service, because we specifically consider the potential for misdirection through poisoning attacks a privacy problem, because you could be redirected and sort of tricked into entering sensitive data into websites that you don't trust. We added a reference to RFC 7766 for mitigations of availability threats, as we consider bad availability of a service also a privacy risk, because people might switch to different services if the service is unavailable. We looked at TLS version and cipher suite combinations as to mitigate tracking risks. We emphasized the usefulness of sharing data for research purposes a bit more, because on the one hand, we want to sort of encourage privacy, good privacy practices in this document, but we do not want to exclude people from sharing data with researchers that might help improve the resolver service or improve privacy on that resolver service. And finally, we added a reference to Mozilla's draft policy for trusted recursive resolvers, and the content of that we leave entirely to them, but we felt that this needed to be included in the draft because it's out there now. And there were some updates to various references. So we think that we've addressed all the suggestions that were raised on the mailing list and in other discussions. We think that we're sort of ready for working group last call. And we want this to remain a living document, right? So this is not the be-all and end-all of the document. What we would like to do is do a biz in, say, 2 years' time, because especially if DOE uptake is going to happen, then we believe that changes will be required to this document, and that needs to be reflected in the future. So a biz in 2 years' time does not seem unreasonable. We are open as to your opinions on this, whether you believe this is ready to go to last call or not. We decided not to separate the policy framework from the operator guidance. That was something that was raised on the list and in discussions previously, and there was not a real consensus on whether to do one or the other. So we debated this between the authors, and we decided that we would rather keep it in the same document, because we believe that as the document sort of gets updated over time, that the operator guidance and the DPPPS, sorry, need to be sort of updated in parallel. So separating them into two documents is just going to be sort of an administrative nightmare. And that's it. Any other things that you would like to discuss, please come to the mic. Paul.
Paul Hoffman, very briefly. So we heard yesterday from somebody on the Chrome team that they're also thinking of doing a TRR and such like that. Maybe we wait for last call until we get some more clarity on that. It would seem funny to have the Firefox one and not the Chrome one. Don't know. And we could be waiting forever, because Firefox one is also still a proposed scheme, not necessarily the one they're using. So I don't know if we want to wait on that. I'll just say that TRR seemed to be like a flashpoint for a lot of people. So us being early and then waiting a few years might be funny. Don't know. Yeah. So I kind of agree with that including one and not the other would be weird. But given on the comments that the Chrome people made in the discussion, I don't think that they're actually going to publish something that is sort of a policy on what they want to do. They basically sketched what they plan to do, but it's not really a policy yet. I don't know what would happen internally within Google before that becomes a policy. I don't know if you want to wait for that. But it's a good suggestion. Any other issues that people want to raise? Because it feels like I'm giving the chairs a lot more time to do other stuff. Yeah. Okay. So
So just to follow up on this one a little bit, how many people have read this latest version of the BCP? Oh, good, about a dozen or so. Excellent. Do people have any concerns with us actually getting ready to start a working group last call on this document? Essentially what Tim and I have been thinking is, hold that hand wave for a second, Paul. Part of what Tim and I have been thinking of is trying to get this document and the 7626 biz document moving because of the essentially the benefits of getting these things out, given with the existing standards. So so what I would like to do is encourage people to read both the 7626 biz document and this document. And Tim and I are going to discuss when to start a working group last call on this. And if you have concerns about doing a working group last call, we'd love to hear about it. Any other comments on this one before we move on? Okay. Pallavi?
Pardon? No, TLS. ZOT. And Han is online too, right? Han is online too, right? On YouTube.
Yeah. Can you hear me?
Hello. So hi, I'm Pallavi RS. I'm going to talk about our internet draft related to DNS zone transfer over TLS, ZOT as we like to call it. There was a small creature also that Willem had found, ZOT. So with me, there is Han Zhang, who is my co-presenter, and he will be presenting online. So first we are going to start with with Han, and then I will continue further. Han?
Okay. Can you hear me?
It's your first slide, Han.
Yeah. Can you hear me?
Yes.
Okay, cool. Yeah. Thank you, Pallavi. So let me give a little bit background of ZOT. So as we all know, the zone data should be considered as privacy. And a few works have been done to protect the privacy. For example, NSEC 3, NSEC 5 are used to prevent the zone enumeration, and the TSIG is used to make sure the zone transfer only goes to the authorized clients. But none of this work encrypts the zone data, so which means the zone transfer is in clear text, and attackers can collect the zone data by passively monitoring the network. And that is the main motivation for us to introduce ZOT, which increases the zone transfer by using DNS over TLS. Next slide, please. Yeah. And here is the timeline for ZOT draft. So early this year in March, we have introduced the first version of ZOT in IETF104. And at the same hackathon, a secondary side AXFR over TLS was implemented in Unbound by William. After that, we updated this draft a lot. We included many details, including the detailed mechanisms for AXFR, XFR based on ZOT, and some authentications, discussions of policy and configurations. And some of them will be discussed in later slides. Next slide, please. And there are three use cases for ZOT. The first one is confidentiality, which means the ZOT will encrypt the zone transfers. And in this case, the attackers cannot collect the zone data by just passively monitoring the network. And the second one is authentication. Currently, the existing zone transfers are authorized by using TSIG. And in this draft, we discussed the possibilities of using different other options. For example, single TLS, mutual TLS, this combination of ACLs. for authentication. And this one will be discussed in a later slide. The third one is performance. So the existing the IXFR's implementation must be backwards compatible. And one burden of this is some old AXFR servers do not support using a single TCP connection for multiple zone transfers. In contrast, the ZOT implementations will be required to implement the optimized transfers, which means multiple zone transfers can be done in single connection. And similarly, current usage of the TCP for IXFR is suboptimal. For example, the TCP connections are closed after a single IXFR, but with ZOT, multiple IXFR can be done in single persistent connection. Next slide, please. And now let's look at the comparison between the existing AXFR mechanism and the ZOT-based AXFR. So as we can see in this slide, maybe next slide, please. We have an animation here. Yes, please. Thank you. As we can see here, the first two phases, including the notify and SOA request, will be done out of the TLS session. But the SOA request can be done in TLS or TCP session. And we do notice that the band already sometimes include the SOA request in the TCP session. So after the notify and SOA request, all the zone transfer will be done in the TLS session, and the zone transfer will be encrypted. And the TLS session will be using the port 853 or some other port that is mutually agreed by both the server and the client. So now I'm going to hand over this to Pallavi. Thank you.
Thanks, sir. So now I'm going to do a comparison between IXFR, the existing mechanism of IXFR, and the way IXFR would be done using ZOT, so iZOT. So in the existing, with notifies, there is not much difference between the existing mechanism and iZOT. The notifies from primary to secondary still go over UDP, and it's kind of the same. For the SOA request and response, the draft recommends that if there is a TLS session that is existing, to reuse that TLS session just to make it more performant. But one of the main things that the draft also recommends is that the existing specifications say that IXFR should happen over UDP. And if the response sizes are too big, there is a fallback on TCP, but which of course adds one extra RTT. If the zone size is big, there is DNSX signed zones with multiple dynamic updates type of thing. So what we have seen is some of the latest versions of Bind and NST do TCP by default. But even when they do TCP by default, for every single zone IXFR transfer request and response, a new TCP connection is opened and closed for every time, despite the fact that if the zone is dynamic, the zone is DNSX signed and is doing a lot of IXFR, every time a new connection is opened and closed. So this draft recommends that two things, using the TLS session to reuse the TLS session to do multiple zone transfers, IXFR incremental zone transfers over a single TLS session, and the draft talks in details about how the secondary can kind of figure out how much longer they want to keep the TLS session open based on their transfer rate and stuff like that. And we have some numbers that we have calculated for a very high zone, a very big zone with DNSX signed and a lot of transfers. So using the reuse of TLS session is one thing that the draft recommends, but also the fact that using TLS gives encryption or protection to the zone data itself. So this is kind of this slide kind of brings out what the draft recommends. The second thing that we would like to talk about is, and that we have brought out in the latest version of the draft, is authentication mechanisms for ZOT. We evaluate the three existing authentication mechanism like TSIG, TLS, opportunistic strict mutual, and ACL on master. And the criteria that we have used for evaluation is data authentication, channel confidentiality, and channel auth. And we are doing this comparison for primary and secondary. So because TSIG is entity to entity, gives us data protection, it works perfectly for data auth. So TSIG is very good candidate for data auth for secondary and primary. And of course, TLS provides channel confidentiality to the data that is on wire during the transport. So all the three modes of TLS, opportunistic, strict, mutual, give you channel confidentiality. But as you can see, when you look at channel auth, strict TLS provides channel auth to the secondary, because of course the secondary will do either the domain name or key pinning to figure out which is the primary. So it provides good protection, channel auth to the secondary, but it doesn't provide the same protection to the primary because primary doesn't know which client it's talking to. So in that case, mutual TLS offers the channel auth type of protection to both primary and secondary. So that is one option for channel auth. But another option that we are considering is ACL on master, which provides good, which is one of the existing mechanism, and it also provides good channel authentication to the primary because now it knows which secondary it wants to talk to. So the conclusion of this analysis is that a combination of TSIG, strict TLS, and ACL on the masters kind of fulfills all the three criteria that we have set for the authentication, and we can get that with like reasonable overhead. So policy management for ZOT. In this draft, we have defined sort of a term called transfer group. Now, in this case, transfer group is kind of captures all of the servers that are involved in zone transfer of a zone for a particular zone, like all primaries, all secondaries. And the entire transfer group should have the same policy in terms of TSIG, TLS, whether it uses opportunistic, strict, or mutual TLS, and ACL for primary, because even if one of the server doesn't follow the same policy, it can be the weak point for any kind of attack. But the challenge that we want to flush out in the draft is how do we configure, test, and or sort of enforce and test policy implementation, because sometimes the secondaries, the primaries could be across operators, could be across different type of implementation. So that is one of the challenges that we have, and we would love to get some feedback from the working group related to this challenge. The last slide for our presentation is just to talk about the current and future work related to ZOT. Unbound has released a version 1.9.2 with secondary side AZOT. This was the work done by Willem during the previous hackathon, and now it's released. The server side AZOT can be implemented using TLS proxy. IETF105 hackathon, we tried to implement support for DOT and ZOT for DNS Java libraries, but that's still work in progress. So some of the open questions that we have asked in the draft, just for performance and better security, would be, should we recommend a must for SOA query to happen over an existing TLS connection? Should we say a must for using TLS 1.3? And the open question is about padding to prevent like traffic analysis type of thing. So our next request to the working group is to review this draft, and we are calling for working group adoption. Thank you. We are open for questions.
Wes Hardiker, ISI. I'm sorry, I haven't read it in detail. I've at least skimmed it fairly well, and I like the presentation. I'm glad this is being documented. I think it's really good. My one question is, you're not adding anything new, right? Isn't it more you're describing the best way to use the existing pieces that we have, like the protocol operations, the transport mechanisms, and things like that?
Yes.
Which is fine.
So we kind of are giving the recommendations of how to use some of these existing things like TLS, DOT, but to do more performant XFRs or XFRs. Yeah.
So I guess my question then would be, I'm wondering what the right status for the document is. I think it's currently listed as a proposed standard, but it's possible informational or BCP doesn't make sense because it's not really long running. We always struggle with that.
Willem will take.
Yeah, so I'm also co-author on this draft, so I want to reply to you to this question too. So this is also an opportunity to improve on existing AXFR. And so we want to, for example, by introducing pipelining, right? Han pointed it out already, but currently if you have a lot of incremental transfers, current implementations will open for each incremental transfer a new TCP session. And if it's all from the same primary to the same secondary, this could be pipelined over the same channel. So it's, summarizing things like this.
Yeah, the optimization is certainly good. My question is that an implementation issue or a standards issue?
This is also a building block for the next presentation.
Yeah.
Ben Kaduk. So I think with respect to should the SOA query be on the TLS connection, I think it should. In general, we don't want people to use some insecure data to determine whether or not they should do something securely. You might notice that your credit card submission form, payment forms on a website are on websites that are entirely HTTPS now. 10 years ago, maybe it was an HTTP site that would send you to HTTPS, but we realized you should just be using TLS the whole way. I don't think there's a particular compelling reason to say that you must use TLS 1.3. TLS 1.3 is great. I think people should use it, but we don't need to use this as a forcing function. There are other versions of TLS that are just fine. They provide adequate security. Padding is good, but you should have DKG tell you how to do that.
Roland Fresick and Elder Labs. Can you go back to slide 9? I think it was slide 9. Yeah. Yep. So one thing I was wondering, and maybe this is a minor consideration, if you keep the session open for multiple IXFRs, then to an observer, they suddenly see that there is a relationship between the primary and the secondary, because to keep that open, it's going to send sort of keep live messages. So there'll be a persistent sort of stream of messages going on that channel. And maybe that is a consideration as well, because if this is ephemeral and you have a connection that sort of happens once in a while, then an observer needs to sort of constantly observe that. And otherwise, by looking for a short time, they can see that there is this traffic going on that they can always observe. And that might be something worth considering. I don't know if that's a real issue or not, but it's something to think about.
Yeah, thanks. Willem, do you want to talk about that? Willem.
So Daniel, relaying for Alison Mencken. She said, another co-author here, this is an update of the existing proposed standards. I see this as a natural proposed standard. And she also said to say that do this with confidentiality and not without.
Yes, so with respect to the relationship between secondary and primary, note that the primary might also be just another ordinary DNS over TLS name server. So it could just be a step client resolver that's having a connection live to the primary.
This is Daniel Kahn-Gilmore. So thanks for doing this. This is great. I'm happy to see it happening.
Thank you.
This is actually related to the Alessandra's presentation, because if you whether you need to keep the session open or not depends on whether or not you're capable of going ahead and spinning up another one rapidly, which the zero RTT would be useful for. So particularly if you say, do this with TLS 1.3, then you can do your IXFR, and as you do it, you get the PSK that you would use to do the zero RTT, and then when you're ready to send the next one, you just do the next one. You can think of multiple TLS 1.3 sessions that have that do it, where each one starts with a zero RTT based on the prior PSK as sort of one continuous TLS
Chain
connection.
sort of.
Yeah, and then you don't need to have the intermediate traffic that was raised as a concern. If you can go back to the final slide there, or what the final slide, that one. So you ask about padding. I do think that it would be useful if we're trying to defend the confidentiality of the data to think about padding, but not just to think about padding, but to think about framing. Particularly for AXFR and larger IXFRs, you're likely to have a number of different records. And as you write those records, depending on what stack you're using, the framing of the writes themselves may be visible on the wire, either in the timing of the packets that are sent or in the TLS frames, right? Like if you just write a blob into a TLS stack and you haven't corked it, then it's likely to send that out as a TLS record on its own. So even if you're doing it as fast as you can, if each record comes out as its own TLS record, then it's visible on the outside on the wire. So you want to think. I would recommend that you do include guidance, and I do think that this is part of the spec. I do think it's worth putting in the standard. Yeah. That you want to, if your goal is to defend against somebody looking at this and telling something about your zone, you need to think about the framing of the TLS records themselves.
Yeah, so in the security consideration, that's what we are saying, that should we use padding so that somebody cannot guess the size of the zone? But this is another consideration too. Thank you.
Wes at ISI again, yeah, +1 to that. That was excellently phrased. With respect to the should must SOA query, I would say it must be TSync protected, right? That's critical. But whether or not it should be over an encrypted TLS connection very much depends on whether the sender and receiver care that the name of the zone is being transferred. So like co.uk probably doesn't care because the authoritative servers are known, you know, if they're transferring between each other, but they don't want the contents of the zone itself disclosed. So it depends on their security properties.
Yeah, so about the SOA, the must is what we are recommending in terms of performance, like, you know, using an existing connection open between the secondary to primary. So that's where our idea was about the must, not in terms of security, what you mentioned. So it was just kind of performance enhancement type of thing, but yeah.
Yeah, it depends on how often you're doing SOA checks. If you're doing them really, really frequently and it's only changing once in a billion years, then...
Yeah.
Hi, Sean Turner. I'm not implementing this, but I'm thinking this is a new protocol. Why don't you just must TLS 1.3? I understand that, Ben, you can do it with 1.2, but just, it's not like it's not available, right? It's already some appreciable percentage of the internet. Just go 1.3 and then you can just, it's an easier way to write it. You don't have to write, if you do 1.3, you do this. If you do 1.2, you do that. This is new greenfield. Just specify must 1.3 or later and be done with it. You can now tell me why.
This is DKG +1 to Sean.
Any more questions?
All right, the next presentation is going to be from Sarah, so she's doing it remotely.
So this is a follow-up to the ZOT presentation. ZOT solves many major problems for privacy of zone transfers, but it still depends on bidirectional exchange for notified triggered incremental transfers. And ZOT is still therefore a polling mechanism for incremental transfers, but there's potential to use in this mechanism a subscribe and publish for zone updates. So what's the ZOT? It's DNS zone transfer encryption using the DNS stateful operations, or DSO. DNS stateful operations are a protocol in which built upon stateful connections that are kept open, and there's where for persistent stateful sessions, so to say, and DSO uses a new opcode to convey new type of messages besides the ordinary DNS queries and DNS answers over DNS stateful sessions. The three types of oh, Sarah's already there. Okay, Sarah. Oh, now she's got. Yeah. So there are three kinds of TLVs already defined. There's the keep live that specifies messages for keeping a session alive and how long a client should keep a session open. Retry delay and encryption padding, equivalent to similar to padding for DNS, but then for TLVs. And other, there's room for more TLVs or more kind of messages for these kind of sessions. Well, so how does the keep live message work? The client sends the keep live DSO message to signal support. The server says, yes, I understand this. Hello, Sarah.
Hi, can you finally hear me?
I can hear you.
Excellent. Do you want to carry on, or shall I take over?
You can take over and say next slide, and I'll push the button.
Okay. So I think Willem was trying to explain the basics behind how the stateful operations actually work. So first of all, a session needs to be initiated by the exchange of a keep alive message between the client and the server. After that, the normal session rules apply and normal DNS message exchange can take place. Within the session, though, you get exchange of DSO messages, and there's two key things to point out about them and how they're different to normal DNS messages. One is that there's two types. There are DSO messages which require a response, and there are also DSO unidirectional messages that do not require a response, and that's okay because we're using a reliable transport. Secondly, a key difference with DSO is that either the client or the server can initiate one of these messages. So that means you have bidirectional data exchange within the session. A last thing to mention is that a DSO message can contain more than one TLV. The first TLV found is called the primary TLV, and that dictates the operation that's actually occurring. But there can be additional TLVs that supplement that operation. So what you can see from this is that the TLVs in DSO messages can be used in several different contexts. Next slide, please. So the key thing is that when you specify TLV, you have to say precisely which context it can be used in. Next slide, please. So the easiest way to do this is to develop a matrix like this. So we have messages which are initiated on the client side, which are shown in the left panel here, and messages that are initiated from the server side in the right panel here. Next slide, please. And in each of those contexts, you separate the two ways a TLV can be used. So in the left box there, we're saying which contexts a TLV can be used in when a client initiates a message. Can it be a primary TLV? Can it be used in a unidirectional message? Or can it be an additional TLV? And in the box on the right, you specify in the response to that message whether the TLV can be a primary or an additional. Next slide, please. So what you can see here is that the keep alive TLV, for example, can be used in a message response pair where the client initiates a DSO message with that as the primary TLV and the server responds with that as the primary TLV. However, it can also be used in a different context where a server sends a unidirectional message just to the client. So there's a lot of flexibility in how the TLVs can be used. And as I mentioned earlier, you can see here that padding, for example, is always an additional TLV. There is no sense in using it as a primary TLV. Next slide, please. So the major place today that has used DSO beyond the base specification are drafts that have come out of the Service Discovery Working Group. And the one to draw your attention to is called DNS Push Notifications. And the motivation for that draft is that clients can be asynchronously notified of changes to specific DNS records. So this is effectively a publish-subscribe model for specific RR sets. It's also used in a couple of other places, the proxy and the relay, but the push is the one relevant to this work. Next slide, please. So we actually owe the push notifications draft a huge debt because we've built directly on top of all the concepts there. We've simply extended them so that they can work for publish subscribe of entire zones. The reason we wanted to do this is because we thought this fulfilled a number of use cases that went beyond what normal ZOT can do. So obviously it ticks the box of confidentiality because DSO can use TLS. DSO itself doesn't require TLS, but anything building on it could, in theory, require TLS. We think there's additional confidentiality gains because the mechanism could eliminate the notify SOA queries or do equivalents of them always within the DSO session. We think there could be security advantages because we can do bidirectional communication within a single client-initiated connection. And this can simplify firewall setups if you have an untrusted network around your secondary. We think we could potentially improve the performance because we can reduce the total number of messages. We can do better error handling because we can define new specific error codes as to why things fail. And a more general thought about this for the future is that it has the potential to be a command channel where servers could initiate commands towards clients, so primary to secondary, and I'll touch on this slightly again later. Next slide, please. So this is a diagram trying to outline the message flow, very similar to the ones you saw in the previous talk. So what we see here is a client connecting to a server and starting with a TLS handshake. Next slide, please. The first exchange is then the client sending a subscribe XFR DSO message. And the content of the TLV in that message is the zone name and the current SOA that the client holds. And if all is well, the server can reply back in the affirmative, acknowledging that the subscription is now active. Next slide, please. So what happens after that is a series of unidirectional push messages from the primary to the secondary as needed. And the idea here is that the primary will keep the state of which IXFRs it has sent, and therefore it can just sequentially send the data as needed. And the current draft proposes that the content of the TLV in these messages is equivalent to the body of an existing IXFR message. Next slide, please. And that data flow will continue until the point that the client wants to unsubscribe. And to achieve that, it sends a unidirectional message to the server. And the content of that message is actually the message ID of the original subscription. And this allows a client to unambiguously cancel an existing subscription to the server. Next slide, please. So a few more details about how this mechanism works. What you can see from that flow is that it's possible for a server to refuse a subscription. And in the draft, we specify a number of error codes that could be used to convey meaningful information to the secondary in that case. Clients can obviously subscribe to multiple zones on the same connection and do the transfers in parallel. We have proposed that clients can request a full zone transfer in the original subscription by omitting the SOA. And at any time, that servers can still send a full zone transfer if they're not able to offer an incremental one because we're reusing the existing IXFR format. Also, clients could unsubscribe and resubscribe on the same connection for the same zone. There is nothing that would prevent that happening. One note is that in the existing specification, we have not yet defined a new TLV that would need to be used for TSIG, because we would need to do that if we want to sign the subscribe XFR message and the DSO IXFR messages. A note in terms of implementation. As you can imagine, implementing this initially will be more complex than ZOT. ZOT's a much, much smaller delta on existing implementations. To my knowledge, no major open source authoritative implementations currently support DSO because it's so new. So clearly that would also have to be implemented before you could move forward with this. But I hope you can appreciate that if you did implement this, you can see that the actual data flow is much cleaner. And the whole mechanism is much more naturally extensible and flexible, and would certainly be very suitable for zones where you have a very, very high rate of IXFR, something on the order of seconds, for example. Next slide, please. So to wrap up, open questions. One of the big ones about the current specification is that due to the fact that the original motivation was confidentiality, the current spec requires TLS. However, I have had a number of use cases proposed where TCP would be sufficient. So, for example, if the zone file is already public, it might be seen as an unnecessary overhead. So there's a question there about, should we allow TCP? My inclination is to say that if we do, we should still have a must that implementation support TLS. We don't split that capability. And if we allow TCP, there is somewhat of a question as to whether this work should stay here or go to DNSOP. So we'd like feedback on that. There's a few of the more minor wrinkles in the spec to still work out. One thought is, should we actually support multiple zones in a single subscription just for efficiency? We clearly need to think about more signaling while subscriptions are active. For example, a client may want to restart the transfers at a different SOA or request an AXFR. We need to think about things like what happens if the SOA refresh timer expires while a subscription is active. In the current spec, we haven't specifically specified an equivalent AXFR message for DSO, but maybe there's a use case for that. I can certainly imagine some use cases where we may want masters to connect to clients rather than just restricting it to client-to-master connections. And as I mentioned earlier, there's some thoughts about the command channel. Two things that were mentioned to me were that people thought it'd be interesting if primaries could send instructions to secondaries to do things like stop serving a zone or delete a zone. And I will also say the C word here, covert, because obviously that's been talked about this week. And what you can see is that this mechanism could quite naturally lend itself to sending other data within an established DSO session. So the feedback we're looking for today is really, do people think this is worth working on, and where do they think that work should happen?
Is the work group interested in this work? That was the last sentence.
Any questions? I think, yes, there is interest in the work. I think this aligns a lot with stuff that came up in the last DNS op meeting, all the discussions about finding a new way to do zone transfers in order to support the requirements of covert and note and things like that. To answer a couple of Sarah's questions, I think while it would be fine to require implementers to support TLS, I don't think it should be required in the operation of it. I can think of a few cases where I'd like to use something like this purely as a performance optimization, where the data is already going over either private networks or there's encryption at a lower layer on the network already, and the TCP or TLS would just be an unnecessary overhead. So yes, I think this is a fantastic idea.
Hello, Matthijs, IEC. Also going into the questions, should we support multiple zones? I think the answer should be yes, almost. Thinking about cases where people have hundreds of zones, thousands of zones they host, like bulk hosting, and that would be a lot of subscriptions to maintain if you have to have a separate subscription for each zone. About the order types, I think there's a need for order messages, like you mentioned, the refresh timer. I could see that being a different DSO message. And then there's additional features like command channels and covert. But you should really think about the scope of the document, and probably those will be separate drafts, in my opinion. And finally, I would say, obviously, I'm supportive of this work, so I think it should be adopted.
Thanks, Matthijs. Yeah, and I think one of the nice things about DSO is that it is extensible, so we could choose to limit the scope of this document to purely the data transfer, and then it would be very easy to add additional TLVs that could introduce parallel data transfers at a later stage.
Ted Hardy speaking. I just wanted to go to the point that you were asking about whether you should move from requiring TLS in operation to requiring TLS in implementation, and to argue that that's probably the wrong direction. Some time ago, the IETF made a generalized analysis of this and said that we want to move as much as possible away from clear text and to move to a situation where, even in cases where it might be permissible to run an unencrypted session, we want to increase the total amount of encryption so that it is expected that everything is encrypted. We're moving toward an encrypt at all times internet rather than an encrypt at only the use cases which required internet, because at the bare minimum that distinguishes the two cases in a way that's signaled to an observer. I encourage you to continue with the requires TLS in operation as the draft currently has, rather than relaxing it. And while I realize that there are cases which people have enumerated where there might be closed networks or other situations where TLS is simply a small amount of additional overhead, I believe in modern implementations that overhead is sufficiently small, and the advantage of keeping to this, always doing it the same way, sufficiently large, that I encourage you to keep it as it is. Thank you.
Petr Špaček, CZNIC. As one of the authors of authoritative server software, I think that we badly need a new transfer protocol. That's a good idea, but I don't think that it should be this one, because it's a lot of work to implement, and I think for the transfer protocol itself, it doesn't go far enough. So we should do like proper transfer protocol analysis and not just say, well, this is how you encapsulate the old transfer protocol in new headers and that's it. I think that we badly need to work on like more fundamental changes in the transfer protocol. So I'm not in favor of working on this and implementing it at all.
Well, it's almost just existing transport, right? It's only introducing the DLVs to convey meta information about the zone transfer.
Yeah, exactly. And that's what
And this
I
is
believe is not worth the effort.
Daniel Kahn-Gilmore. So a +1 to what Ted Hardy said about just make it TLS, and that's the mandatory, that's how it's done. I don't think the cost is too high. I will note, if it's not TLS, then it's not clear why it would be in DPRIVE. It's kind of an interesting situation. And secondly, I'm a little puzzled by the use of TSIG within this when you have as an established secure session. We talked a lot about this in the web packaging side meeting earlier this week, but the relationship between the transport model of authentication and the object model of authentication, which DNS is super used to using, is unclear, and here you've got this weird mix of things. So I'm not sure what you get from the pairing, and it just feels a bit like a mismatch, and I don't understand it.
So TSIG authentication is end-to-end authentication of the primary and the finally receiving name server that will serve the zone. So there could be a number of proxies between them doing that, so to say, or talking over TLS, right? And you have to trust all these, without TSIG, you have to trust all those proxies that they convey the data. Yeah.
But so if there are proxies involved in this, which it hadn't really talked about, then, I mean, the thing with TSIG is that it's also replayable, right? So if I get a copy of it, I can now replay that TSIG and do it in other contexts that maybe it wasn't appropriate to do. And I don't understand TSIG well enough to be able to investigate that, but I'm just saying that to take the TLS model, which says, here's a stream, you've established the stream, the two sides of the stream have certain identities, and then say we're going to pass within that an authentication token that's not itself bound to the TLS stream, it sets off the warning flags, but I don't know the details. So I'm just highlighting that as a potential source of tension here.
Yeah, it's also a cheap method for the master to authenticate the secondary, because otherwise you would need to have mutual TLS authentication, which is inconvenient, right? Or people consider that.
But if you were to go to the TLS working group and say, we need a way that we're trying to do something like this in DNS over TLS, and the server needs a way to authenticate something about who the client is, then you'll get answers that are very different from TSIG. You'll get answers that are bound specifically to the encryption channel that is in use. So anyway, I'm not going to design at the mic here. I'm just pointing out that I feel like there's a mismatch here and something that we should think.
Okay.
I was actually going to do the same thing. So there's a common operational paradigm for zone transfers is I trust you to transfer this zone, and I don't care where you transfer it from. So mutual TLS authentication is inconvenient in that case. All I would care about is that we've negotiated TLS so that it's encrypted. And I don't care where you're negotiating it from, so I don't need to validate that your certificate matches your host or anything like that. In that case, having TLS for the encryption, but TSIG for the client authentication would be useful.
Note that the zone checksum draft that we're offering also kind of solves that problem.
So while Flavi's getting up there, I'm going to cut the mic line at Ben, maybe? No?
No.
Okay.
Just as we, sorry. So what we mentioned in the data auth during the ZOT presentation was what TSIG does, and which applies equally to the Z piece also, is that what TSIG would do is whatever the primary is saying that I'm going to send you in terms of the XFR response, it will take that data, whatever like 2 RRs or 3 RRs, and it will do a hash on it, sign that hash using the shared secret, and then send it to the client so that the client knows that once I verify that using what shared secret I have, he did mean to send 3 RRs and I did get 3 RRs. So it's kind of like, the data itself also gets authenticated from both sides, not just the TLS, not just encrypting the data, but authenticity of the data itself. So that's what you buy with the TC.
Wes Hardiker, ISI again. So correct me if I'm wrong, but there's two halves of this essentially, right? There's one half of this is how we want to do, secure push notifications and stuff. The secure and the push seem to be totally independent. There is nothing in the document that requires TLS in terms of functionality. There's a requirement we want to do it in DPRIVE and we want it to all be encrypted. Great, but the push notification side, this seems like completely the wrong working group, and it should really be in DNSOP. All you really require is a streaming transport. And, being able to specify in DNSOP, we need a streaming transport. Oh, and it must be TLS 1.3 is just fine. But I want the experts in the DNSOP group to, although I keep looking around and they're all here, but it still feels like the wrong place.
Okay. Hi, Puneet with no hats on. I think I'm echoing Peter Spasek's comment that there seems to be a general need to redesign zone transfers. So I'm also in favor of starting from scratch and looking at the requirements for zone transfers and then building on top of that rather than trying to retrofit. And the other observation on complexity, this assumes that DSO is also implemented, which is a fairly large spec. So I think to get to this point would require an implementer to do a lot of work.
Okay, thank you.
Yes, okay. Just for my own curiosity, how many people have read this document? Okay, and how many people have read the zone transfers over TLS document? Excellent. So I'm going to chat with Tim to see how we want to proceed with these, but if you have comments or feedback, please provide them to the mailing list. Thanks. I believe Michael is now up.
That's not it. That's it. I get a clicker. Does it work? Okay. Okay, not for me. Clicker doesn't work for me. All right. It's a treacherous computing module. Hi, my name is Michael Richardson. I'm here mostly talking on behalf of Tiru and Dan, who couldn't come to this meeting. I get roped into this because they decided to incorporate my protocol into their stuff. So what this is about how your, let's go to the thing, what we're talking about. Document has advanced a bunch, okay? What are we talking about? We're basically talking about how to bring on, install trust anchors for DNS over TLS or DNS over HTTPS things. And the scope is you show up with a device or an IoT device at an enterprise, and you would like it to use the DNS over TLS with the local trust anchors, because you would like to get local names and not remote names, because you would like to have access to whatever enterprise mandated malware defense that's DNS based. And we have a new use case, which is particularly care, is that we have this manufacturer usage description MUD files, And this is essentially a mechanism by which IoT devices can express, here's a white list of traffic and communications that you should expect me to do. If I do anything else, I'm compromised, and please act appropriately. The problem is that we'd like to write those ACLs in with DNS names and not IP addresses, and you may have noticed that firewalls mostly don't speak that at the low level. They need IP addresses to do enforcement. And the only way that works is if essentially the request for the DNS name that the firewall does and the request that the IoT does essentially resolve through the same resolver. Otherwise, we get into all sorts of geolocation and all sorts of other DNS things that happens with cloudy things. And the result is the firewall has a different set of addresses than the IoT device in terms of what goes on. There's also some efficiencies. If they turn out to both go to the same resolver, then it's already cached, and there's some other things that you can do, and it reduces some of the stuff. So this is about how do we get this to happen. So there's a couple different ways that described in the document. The document describes 3 or 4 different ways, and there's another document, I believe it's Thomas Fossati, that talks about doing this in DHCP v4 in a slightly different way than we've described, and I'm actually not qualified to tell you the differences at this point. But if you do this with an IoT device or an enterprise router of some kind that's running the Anima-Brewski process, then essentially what happens is then that process, their device enrolls into a enterprise PKI, and when that device does that, well, you get the trust anchors. That's the whole point, is you are now a device on the network, and you get to trust other devices. And so now the only real question is, what's the name of the DOT or DO server, and how do you look it up in the certificate? So it's actually really easy in that case. There's almost no moving parts to add. If you are bootstrapping a desktopish kind of machine into this PKI, then you're probably going to have some kind of, if you use EST, which is RFC 7030, to do certificate enrollment for that device, then you may have a password of some kind, and you need to authenticate over that thing, and you can use PAKE or something else like this to authenticate, in which case, again, you get back trust anchors, and you have an end certificate, and you can validate the DNS. This kind of thing happens, I'm told, regularly right now, actually using CMP with, I think it's Apple devices, which are in enterprises. I have no first-hand knowledge of that. There's a discovery phase. This is the part that I'm going to say I'm least qualified to understand. So if you'd like to ask me questions, that would be funny. But essentially, you look up this domain-s, and you do a service discovery on it, and it tells you where the DNS server is, and you go and find it, and then you find it has a certificate which is signed with the appropriate name in the thing, and you had a trust anchor from before, and everything is good. And there's another document that tells you how to do that part, how to get the right URLs out. So if you're doing DO, you need a URL that you're going to add to it, and there's another document. It's not our document that says how that's happening. And I mentioned you have to do the connection, and you have to match all the things, so I jumped ahead of my slides. There we go. One of the things we would like to have is we would like to have some way of asserting what the privacy considerations of the server that you're talking to is. I recently learned, I think that Mozilla has a statement that, for instance, relates to Cloudflare and how that happens. And one of the interesting questions is, well, how can others play and get an attestation from some third party that says that the DNS server running at your enterprise is not scribbling DNS requests, out the unencrypted channel somewhere to somebody, right? And or writing them or logging down or whatever it is your policy, we would like to be able to write it down somehow and attest it to the end user so that their device can say, oh, okay, this actually is a legitimate thing, or wow, while I'm at this particular location, my Tuesday job, maybe I won't be turning on my laptop or something because I don't trust the DNS. You'll know at least. What did I do here? I broke the slide. They should be able to enable this discovery, and if they don't want to enable it and they don't want to discover the local thing, they're not going to get local names and this kind of stuff, and that's really applicable to devices that you would bring with you. For an enterprise with IoT devices that they want to onboard, then, well, they want to enable it. And they particularly want to enable it because otherwise they have difficulty defending the IoT devices from malware. They also have difficulty defending the internet against the IoT devices properly. Comments and questions? Anyone read the draft? Hey, a few, 4. Sean.
Hi, Sean Turner. So this is a PKI thing, so you can just tell me to shut up and sit down if you want. Do you really need a new certificate extension?
We thought that needed to be in there to attest to the policy.
Right, because
Right.
there's already a certificate policies extension where you can put this kind of stuff there. But
Yeah,
you've already
doesn't that
done it.
involve lawyers though?
This might as well. I don't know.
Yeah.
It says policy, right? Like, 'cause if you're putting things in a certificate, you're supposed to have certificate policy, and you're going to specify what things would go in there, and it would be covered by the policy anyway. So it's already going to be in the policy.
I'm going to say that we wrote that in because of a partial partial willful ignorance that we don't really want to go into that space. But I accept that what you're saying is that probably we need to be in that space. I think the more interesting question is, who is going to provide that attestation? Because it's caught in the enterprise, it's going to say we're trustworthy. It's got to be something that goes into the certificate that says this key that you've just found in this enterprise has something, and we've reviewed their policy, blah, blah, blah. They've posted it here or whatever. Okay. I don't know who that entity is. And I think maybe the form of that thing would be determined by that entity more than us.
Fair enough.
Okay.
Yeah.
Do you know of such an entity that might help us that way?
I'll think about it.
Okay. Any other questions? I don't know that we're interested in being adopted at this point. I think this is still too nebulous to know even if it fits in this working group, but thank you.
All right, I'll be quick. I don't have much for slides. So three of us put out a draft for authoritative operational considerations for running authoritative dot. We put out the draft right before the deadline, and I think we've already published the 01 version. And then one of the major comments that came out of it is we're not trying to discuss the merits of running dot to the authority. We're trying to discuss some of the considerations that anyone who may run dot on an authoritative server might want to think about, or we as a group may want to try and look into before it starts getting wide deployment around the world. So here's the list of the key topics that we talk about in the draft, mostly focusing on things that we see as mostly different for someone running an authoritative versus a recursive, where if a recursive goes down, the end user may choose the secondary recursive, but if all of your authoritative servers go down, then domain's going to be unresolvable anyway. You can't pick a new authoritative for it. And then like system tuning, it includes TLS parameters and monitoring and TLS parameters and how you may want to tune the system for like resumption and renegotiation and how you divide the traffic between different systems. The current status of the draft is like I said, we put out the 01. We have a couple more items from the list from some of the comments and feedback we got already. I pushed a new update to the 1.1 section of the draft that we'll try and get out in the next couple days. And then we have a couple more things to address from the comments we got already, but we should be done with that fairly soon. We're looking for any other people that want to comment on it, have questions, and then potentially even being adopted by by DPRIVE. That's all I promised Tim we'd be quick. That's all I had.
So we do have a couple minutes. Does anybody have any comments for Tim and the other authors?
So I saw, I'm not sure if I remember correctly, but there was a mention in the draft to run the TLS on a different port. Can you clarify why?
About which on a different port?
Running the TLS endpoint on a different port on the server side than the unencrypted server.
So by running on an 853 rather than 53?
Okay, I take that back. I'm confused. Sorry.
Okay, we did leave it open for one of the considerations in there is whether or not, or we trying to be able to figure out how to do let the recursive find the authoritative server through some sort of communication pattern that doesn't currently exist, where if you're a client talking to a recursive, either the client configured it or it's configured in the application or something like that, where there's no current mechanism for the recursive to go and find the authoritative. And one of the things there is the port number of 853 is in the DNS over TLS RFC, but it's not mandated to be that. It's just I'm trying to remember the wording. I thought it said it's 853 unless configured mutually agreed upon to be otherwise.
Yeah, Carl Henderson, this is VeriSign, from VeriSign. So one of the considerations that went into that as well is maybe downgrade attack prevention as well. So that's another reason why we're considering being able to configure a different port.
Thanks. So we do have a couple of minutes left. If anybody has any topics they want to bring up or questions. I'm certainly not going to stand between you guys and wherever you want to be. So thanks, everybody. Read the documents that need to be reviewed, and we will see you next time. Thank you very much.
Whoever has the other blue sheet, or anybody who didn't sign the blue sheets, come to the front and sign the blue sheets.